Welcome students. Today we will start motion in a straight line. Of course in class 9 we have covered this. Let us repeat. Motion. If a body changes its position with respect to its surrounding, then body is said to be in motion. Rest. If it doesn't change its position with respect to its surrounding, then it is said to be rest. Types of motions. One dimensional. If a body covers in one direction only. Two dimensional. If it is covered in two directions. Three dimensions in 3D like x-axis, y-axis, z-axis. Distance. The actual path travelled by an object is distance. Displacement. The shortest distance between two initial and final position. Suppose I am telling here let I want to move from A to B. Suppose I am moving, this is my original path. This is my distance, and displacement is the smallest distance between two points, initial and final point. So this point is, this line is displacement, this is distance. Distance is scalar, unit is meter, displacement is vector, unit is also meter. Always arrow mark is given for vector. Speed, the time rate of change of position. Of course, speed is v equal to ds by dt. We will learn. Class 9th formula is s by t. Uniform speed, if a body covers equal distance in equal interval of time. Non-uniform, if it doesn't cover equal distance in equal interval of time. Average speed, total distance travelled by total time, is known as average speed. Now let's go for the next part, instantaneous speed. At any instant, if I want to know speed of a body, is known as instantaneous speed. Now where limit time, change in time tends to 0, del s by del t is known as derivative. Change in distance with respect to time is known as instantaneous speed. Velocity, rate of change of distance with respect to time, ds vector by dt. Acceleration, rate of change of velocity is known as acceleration. Let's discuss a little bit concept which is required from math, that is derivative, which is important. Then we will go for graph. The point I am telling now for 5 minutes, derivative. Suppose I am telling v, what was the definition I told? Dx by dt. Suppose this is the distance travelled in total time t, A to B. I will divide it into small sections. Let each section is del x. So what is this distance? I'll break into del t, means small change in distance with respect to small change in time. Anything which varies with respect to another thing is known as derivative. How can I read this? I'll write derivative of x with respect to t, which is speed. All the physical functions you will know in mathematics. For now, just let us know its formula. So here x changes with respect to time t. What are the formulas? Let us know. dx to the power n with respect to x. How will I read this? Derivative of x to the power n with respect to x. What is its formula? N into x to the power n minus 1. Now I will go for some example. For example, x to the power 5 with respect to x. So how can I solve it? Here n is 5 into x to the power 5 minus 1. So it become 5 into x to the power 4. This is the first rule. Let us go for the second rule. Derivative of constant is 0. If k represents some constant, derivative of constant is 0. Suppose I am writing here 5 is constant, is 0. Suppose I am writing here derivative of some constant into a function which depends on x. Then constant will move outside. This is constant, it will move outside into derivative of function. That means I will write here, for example, derivative of 5x to the power 4. Here 5 is constant, it will move outside. So I will write derivative of 5x to the power 4 with respect to x is 5 will move outside. Now x to the power 4. This formula I will apply it from here. That is 5 into n is 4 into x to the power 4 minus 1. So it is 20 into x to the power 3. Let's go for some other problems. Then we will apply it in our physics. Suppose I am writing here derivative of a function fx plus or minus gx. What will I write? Derivative of function fx plus derivative of function gx. For example, this is the third law. I am writing here derivative of x to the power 4 plus x square. I will solve like this. Look it here. Derivative of x to the power 4 with respect to x plus derivative of x square with respect to x. Again, n into x to the power n minus 1, n into x to the power n minus 1. Similarly, if it is minus, then we can solve like this. So for physics, this is sufficient. I will give some examples, you will solve it, how it is applied in physics. Suppose I am telling a displacement of a particle is represented as 4tq plus t plus 5 meter. Find its velocity and acceleration. Find velocity, find acceleration. That means I have to find here v is dx by dt. That means d by dt of 4tq plus t plus 5. How will I solve? D by dt of 4tq dt dt. But here derivative of constant is 0 and here 4 is constant, will move outside. So So the next term will be 4 derivative of tq with respect to t dt by t. Now here n into t to the power n minus 1. Similarly 1 into t to the power 1 minus 1. That means dt by dt is 1. So here 12t square. Suppose it is asked at time t equal to 2 seconds find. So what should I write? At t equal to 2 square, that means 48 meter per second. Now suppose the next part is how to find acceleration. Integration is also there, we'll see inside class. Acceleration is dv by dt. That means d by dt of this equation I will apply. 12t square. So 12 is common. Dt square by dt. That means derivative of t square with respect to t. Again n into t to the power n minus 1. That means 24t. So we got acceleration. Suppose acceleration at t equal to 3 seconds question mark. How to solve? Now I will write at t equal to 3 seconds 24 into 3. That means acceleration at 3 is 72. Obviously unit is meter per second square. Students, always remind, if you miss unit, you miss the mark. From here we got how to solve if distance is given, how to find out speed, how to find out acceleration. Now the question is there, from here what are the other things we can find? We can draw the graph. We will see in next class.